All right, so today, first of all, welcome back from break. I hope everybody had a nice winter break and New Year. Today we're going to be able to set up proportions using given information. So what you guys will get is a word problem. What you'll actually be doing later on is solving these, but for now we're just going to set them up. So let's see, Samuel can run 9 minutes per mile. How many miles can he run if he ran for 31.5 minutes? So we're going to look at this. We're going to set up a ratio first, right? So let's set up ratio. We're going to look at 9 minutes per mile. So we're looking at minutes and miles. So I'm going to write minutes over miles. All right, and from here I'm going to set up two more ratios, creating a proportion. So what I'm going to do is pull out my handy dandy highlighter tool, which might be helpful for you guys. And I want to mention that wherever you put minutes, it needs to stay consistent. So if you put minutes in the numerator, minutes need to stay, all minutes go in the numerator. If you put miles in the denominator, all instances of miles will go in the denominator. All right, so we have kind of a template set up. So Samuel can run 9 minutes per mile. All right, so we have 9 minutes. We have 9 minutes. And we know that per mile is just going to be 1. That means every mile he can run it in 9 minutes. So how many miles can he run if he ran for 31.5 minutes? Well, let's take what we know. We know 31.5 minutes. So I'm going to put 31.5 minutes in there. Now let's look for what it's asking. It's asking how many miles. Well, I don't know how many miles, so I'm going to use a variable. All right, just remember, wherever you put minutes, it has to be consistent. All right, and you'll see, and when we do this one, why. So your trick is just to look for X's partner. X's partner is always going to be diagonal. Always going to be diagonal. All right, so where does X connect? What's X's partner, his teammate, whatever? It's going to be across and diagonal, right? So across diagonal. So we're looking for where X and 9 are partners here. And the cool thing about this is this works for every proportion, okay? So where X and 9, so here I have X and 1, so that's no good. Here I have X and 1 again, that's no good. Here I have X and 9, so that's looking pretty good. Let me put question mark there. And here I have X and 31.5. So we know D is not going to be the answer. So B is definitely our answer. Well, you might be saying like, but that doesn't look the same as what we wrote. Well, it's because you can write these 4 different ways, at least, right? 4 different ways. And if you notice, the only difference is where they put minutes. They put minutes down at the bottom. And they put miles at the top. But the most important thing is, and they kept it consistent. That's the key here. But what makes this little trick work is that our 9 and our X match up. All right, our 9 and our X are partners. So B would be our correct answer. All right, just like the last one, Ramon drives 150 miles in 3 hours. So again, let's start off with miles over hours. And then set up your proportion. All right, and don't forget, I'm going to highlight this one again just to drive it home. But be consistent. If miles are in your numerator, that all your miles go in your numerator. If hours is your denominator, all your hours go in your denominator. All right, so Ramon drives 150 miles, all right, in 3 hours. If he's driven for 12 hours, so that's another given, so we know that that's going to be in our 12 hours. How many miles has he gone? How many miles? So it's asking us a question, and we don't know. So we're just going to put our X in for miles in our second fraction. All right, and we're going to see where X's partner is. Remember, the partner is diagonal across, diagonal. All right, so let's come down here and look for where X and 3 match up. Well, for A, X and 12 is no good. C C is 150 in X, so that's no good. D is again 12 in X, that's no good. And B is again 3, or B is 3 in X, so we know that B is our correct answer. I know you're saying to yourself again, but it doesn't look the same. Well, look, I'm going to pull out my highlighter. Miles, for us, is in the numerator. For the next question, it is in the denominator. Hours is in our denominator, but for the answer, it's in the numerator. So as long as they are consistent, this works. Another big thing, the biggest thing, is knowing this X finds its partner, right? And that matches up for us. This trick, this X finding its partner, will work for every proportion. All right, you're going to get some that are going to be percents. Well, there's a couple of things that I just want to point out. First of all, we all know that percents are always over 100. Another way to write this is that you're going to have part over your total, right? Or part over whole, all right? So when it gives you a percent, like 70% here, that's automatically going to go right into our percent area, all right? Because we know that 70% is always going to be out of 100%. All right, so with that kind of said, Dillard surveyed 210 customers about their store. Of that, 70% said that they were satisfied with the store. How many people were satisfied? All right, so let's talk about this. Easy part is getting your percent right. 70% over 100%. All right, now we have our other fraction. So again, I just want to kind of point this out is you have percent over 100. All right, well, over on our other side, we're going to use what we just kind of went over, which was part over whole. And we have to look at what the question is asking us. So the question is saying, how many people were satisfied? All right. Let's see, Dillard surveyed 210 customers. So that means out of 210 customers, we want to know how many of these people were satisfied. It tells us that 70% of them were satisfied. But we want to know how many people were satisfied. How many is that 70% out of 210? So that means my 210 is going to be my whole, because that's everybody that got surveyed, right? Every Dillard surveyed 210 customers. 70% were satisfied. How many people were satisfied? And this one we're going to use our variable. All right. And just look where X matches up with its partner. Remember, that's going to be diagonal across. And if I come to A, I get X matches with 70, which is wrong. B again, X matches with 70. D again, X matches with 70. But C here, X matches with 100%. Now, another little trick here that you might be able to use is you notice that right away we had our 70 over 100, right? Let me come up here. Right away we had this 70% over 100%. I'm not going to say that this always works, but if you get into a place where you have to guess, know that 9 times out of 10, we're going to start off with it as 70 over 100 like we wrote. So you can see here that that's not going to work. And you can see here that 70 over 100 is not going to work because it's 100 over 70. But again, that's if you get into a guessing game. Do not use that. Your big trick is knowing that your X's partner is the diagonal across in this one, which is 100%. All right, people were polled about their favorite movie type. The results are below. If 45 people say they enjoy action movies, how many people were polled? All right, so again, we have another percent because we have a pie chart. And everybody should know that a pie chart deals with percents. So let's see, it says people were polled about their favorite movie. The results are below. So 45 people say they enjoy action movies. So let's look at action movies. All right, so again, we're going to do this percent over 100, which for action movies is going to be 30%. And that's going to be over 100%. All right, that's going to equal another fraction. Well, remember, we're talking about a part to the whole or to total. Well, what's the question asking us? It's asking us how many people were polled. All right, so that made me believe that we are looking for our total amount of people polled. And this kind of works, they go hand in hand because we know that it says that only 45 people enjoyed action movies. So if these are our action movies, only 45 people enjoyed them. And that's just a part of our whole, right? Because only 30% like action movies, which means only 45 people is 30%. Right, and again, we're just going to see where X matches up. And you have X matches up with 30%. And use our handy dandy trick. A's out. X matches up with 30%, does not. Matches up with 100%, does not. And here we go, X matches up with 30%. So the answer is D. Again, not the best trick to use, but notice that we don't have our 30% over 100, right? So B is definitely gonna be wrong. And you have 100 over 30, and that's 9 times out of 10, again, is gonna be wrong. But your big thing is realizing that your X's partner is diagonal and across, and they match up with what we had. So D is the answer. All right, last one of the day. See, you baked 36 cookies, 2/3 of your total were chocolate chip cookies. How many chocolate chip cookies did you bake in total? Now they're gonna throw in extra words here, like in total. That's gonna make you be like, oh, looking for the total. Let's really think about this. First of all, let's look at this 2/3. If the question gives you a fraction, and everything we've been doing has been with fractions, I would strongly suggest you use this fraction. All right, and what we're gonna have, we're just gonna start off with 2/3 and our other part of our proportion. Well, what does this 2/3 mean? What does this 2/3 mean? All right, it's saying for every 3 cookies, for every 3 cookies, 2 of them are gonna be chocolate chip. All right, 2 of them are gonna be chocolate chip. That's what 2/3. So your total is 3, and out of your total, you get how many were chocolate chip. All right, so now we have to look for our chocolate chip and our total cookies. Well, we know that you baked 36 cookies. So I baked the total amount of 36 cookies. All right, so that's gonna be my total. But I wanna know how many chocolate chip cookies, how many chocolate chip cookies did I bake? Well, if you set it up with this chocolate C on the top over here, chocolate chip cookies on the top, then you'll know that your variable is gonna go in the numerator. And we just find out where X's friend is. And you will notice right away that A is your correct answer. But because we're good students, we will check all of them, and you'll notice that the rest of them are incorrect. All right, so that's all we really did today. Tomorrow, we're gonna build on this because we're going to have to continue to create these, but then we'll solve. So we'll get plenty of practice in creating them, and I think the solving part won't be an issue at all. Other than that, if you have any questions, ask your teacher. Make sure you get your Unit 7 test done if it's not done already. Have a good afternoon.